our show today. We're going to tell a couple of jokes.
All right. So
why couldn't the toilet paper cross
when we are solving for our roots, right? We had, let's go back and look at a quadratic that we had once, like this, and we could factor that, right? What did we factor that into? What do I multiply equals 4 but add equals 4? X plus 2, x plus 2. So we say x plus 2 squared, and what's my root then? Okay, so this is one root, but I have told you that you have the same number of roots as you do degree of polynomial. So if this is a second degree polynomial and I only have one root, something's not right. And what's not right is this root of -2 actually happens twice. And we say that has multiplicity. So -2 is my root, but now, today, we're going to say with multiplicity of -2. Not -2, of 2. Because it happens twice, okay? So if something happens more than once, it's called multiplicity. And what happens when we have multiplicity on our graph is that at -2, my parabola is coming down, touching -2, and then going back up. Whenever you have a min or a max touching the x-axis and causing a root, it's going to have a multiplicity of 2. Yes, because squared means it happens twice. Okay. So if you look at the first example here, right, I have x plus 3 cubed. What does cubed mean?
3 times.
It happens 3 times. Very good. So what is my root? What is my root? X equals what? What's going to make that equal 0?
-3 cubed.
Very good. -3 is my root. But how many times does it happen? 3 times. So we say x equals -3 because that's what makes this equal 0. And then we say with multiplicity of 3. Okay. You can abbreviate, yep. So look at this one down here. I'm going to go out of order a little bit. This is x minus 4 squared. What does the squared mean? It happens twice. So what is my root? What makes that equal 0? 4, because 4 minus 4 is 0. Good. And then we say 4 is my root, but with multiplicity of 2. Right, because it happens twice. Good. Okay, let's try another one of those. So like this one, I have 2 roots. When x is a factor, 0 is a root. Very good. And what's my other root? Positive 1, because 1 minus 1 would give me 0. 0, right, that's just an x there. So 1 happens how many times? 3 times, because it's cubed. That means x minus 1 is happening 3 times. So x equals 1 with a multiplicity of 3. Let's do one more of those and I'll show you some factoring. So look at 32 down here. What are my 2 roots? X equals 2, x equals 1. Which one has multiplicity?
2.
The 2, very good, because it's squared. That means x minus 2 is happening twice. So we say with multiplicity of 2. Good. So you also need to, sometimes it's not going to be in factored form for you. You're going to have to put it in factored form. So whenever you're factoring, your first step should always be, can I factor something out? Because whenever you can factor something out, it always makes it easier to factor. So spoiler alert, all of these you're going to be able to factor out an x, right? Okay. When I factor out an x, what's a root? 0. Whenever you factor out an x, whenever x is a factor, 0 is a root. So I look at both of these terms. What do they have in common besides an x? A 3. So I can take a 3x out of both terms. What's left? X squared. What's left? Nothing but a 1, right? There's always a 1 left. Now we have to continue factoring this. What do I multiply equals -1 but add equals 0? Why 0? There's no x term, right? There's no x term right there. So I could rewrite this as x squared plus 0x minus 1. So my factoring question is, what do I multiply equals -1 but add equals 0? 1 and -1. Now it's factored all the way, right? What are my roots? If x is a factor, 0 is a root. And then write, what plus 1 gives me 0? -1. What minus 1 gives me 0? +1. Right? It was a cubic function. I could see in this problem my highest power was a 3. So I better have 3 roots, and I do. Let's try another one. 29. What can I factor out of every single term? An x. Very good. So factor out an x. Right? I still have a quadratic. I need to factor that. That's why we practice some factoring. 2x squared. 2 can only be 2 and 1. -1 can only be 1 and 1. So how do I get an outer inner to be a +1? Well, it better be a +2x and a -1x. So my outer inner is +1. Or you can do the long way, right? The long way is take the a to the c term. What do I multiply equals -2 but add equals 1? If the 2 goes away, the 2 has to come back in. Can I take anything out of 2 and 2? A 2. Can I take anything out of 2 and 1? No. Whatever factors out goes away, and see how I have the same factors? It's just going to take you longer. That's the downfall. It's going to take you longer. Okay. But now that I have it factored, what are my roots? 0. -1. What about this one? I'd have to set it equal to 0 and solve for x. So I would add 1, divide by 2. What's my root? 1/2. Right? If I set this equal to 0 and solve for x, I would add 1, divide by 2, so I get x is 1/2. Okay? Look at some more factoring. What can I factor out of this one? An x, right. So take out an x. What do I multiply equals 10 but add equals 7? 5 and 2.
5 and 2.
What are my roots?
-5 and -2.
0, -5, -2. Right. Because what plus 5 gives me 0? What plus 2 gives me 0? Good. Let's do the one below it. What can I factor out? An x. Very good. Factor that. What do I multiply equals -36, but add equals 0? There is no b term there, right? It's 0x, 6, and -6. Very good. What are my roots? 0, -6, and +6. Very good. All right? It's a cubic function, so there better be 3 roots. That's how you check yourself. Make sure you got them all. Okay, what can I factor out again? X.
What number are we on?
3. Okay, now factor that. What do I multiply equals -18, but add equals -7? Very good. -9, +2. What are my roots? 0, think maybe just a couple more. Let's try the one below it. What can I factor out of every single one?
2.
X. What do I multiply equals 16 but add equals 8? 4 and 4. Which I can say x
Squared.
and x plus
With
4
multiplicity.
squared. Very good. This means I have multiplicity. I have 2 roots, 0 and -4, but this is squared. That means the -4 is happening twice. So we say -4 with multiplicity of 2. It's going to happen twice. I still have 3 roots. It's a cubic function. I have 0 and I have 2 -4s, so that's still 3 roots. One more when a isn't 1. Let's do one more of those. Because those are the tricky ones, right? What can I factor out of every single term? 3x. 3x from every single term. Factor that. Right, so here's some mental math. I know 3x can only be 3 and 1, and 1 can only be 1 and 1, but I need the outer inner to be a positive 2. So this has to be a positive 3x and a negative 1x to give me a positive 2x. Okay. One more time, let me show you the other way. I take the a to the c term, factor this. What do I multiply equals -3 but add equals 2? Oh, plus 3. Okay.
But
Then
C term comes back.
the c term comes back. What can I factor out of 3 and 3? A 3. What can I factor out of 3 and 1? Nothing. Whatever factors out goes away, and see it's the same factors. Okay. Now, what are my roots? 0. Whenever x is a factor, 0 is a root. -1. And how did we do this? Set it equal to 0. Add 1, divide by 3. So 1/3. I wanted to put a couple of these in so you can see what you're solving, because a lot of times students have a trouble making that connection. So we're going to write the factored form of this using the graph. That means I need to know what my roots are, right? In order to have the factored form, I need to know what the roots are. I don't know how to factor this yet. Okay? So let's open up the graphing calculator. And graph it. Put in your y equals x cubed plus 7x squared
X cubed plus 7x squared.
plus 15x plus 9. Right? Just put this in your y equals. And then graph. And what are you looking for on your graph? Where are my roots occurring?
I did not get that.
Where it crosses the x-axis. Very good. So what I see here is it's crossing the x-axis at -3 and a -1. That means those are my roots. X equals -3, x equals a positive 1. Right? That's how you can check yourself on your homework too. Graph it and see if your solutions match your graph. But the big thing I'm missing here is if this is a cubic function, I need 3 roots, okay? So one of the hints I gave to you at the beginning of class, if I ever have a min or a max hitting the x-axis, that has a multiplicity of 2. So see how your graph's coming up? It's hitting the -3, creating a max there, and then coming back down. Since I have a max at -3, -3 has a multiplicity of 2. If you ever have a minima or a maxima hitting right? The x-axis, it's going to have a multiplicity of 2. Right. Yep. So if I had a graph that was like this, it went through the 2 and then came back down and hit here, right? So I'd have a root at 2 and then a root at 6, but see how now I have a minima hitting the 6 here? That would have a multiplicity of 2. Whenever it hits the x-axis and goes back up, or hits the x-axis and comes back down, creating that min or max, it has a multiplicity of 2.
So that's it?
Right? That's a really big thing to know, and
That's
not
how
so
you
much in
do
Algebra
that?
2, but when you continue into like pre-calc.